Welcome to the third video of hashing, where we'll discuss collision resolution technique, and in collision resolution technique we'll discuss linear probing. So let's discuss what first, as we have already discussed in our first video what is collision. So here we will discuss collision resolution technique. That start. So let's have a recap of collision. So what collision was, so I took an example, hope you remember if you have seen my first video, that taking element 44, when we apply a hash function, our hash function is mod 11. So when we apply a hash function on 44, that is 44 mod 11 is equal to what is, you get 0. But 0, and if you see this hash table where 0 is already occupied by 77, but 0 hash value has already been occupied by element 77. This problem is called collision. So this is the problem called collision. So if this is the problem called collision, this, what does this means? Will we not store 44? No, we will store 44. We know that there is a collision, but we will have to resolve it. Fine. So this is the figure which we have already discussed in video number 1. So if you can see that k1 is taking this position after applying hash function, k4 is taking this position after applying hash function, but k5 and k2 are taking this position. So this is where you are, something which is occurring is called as collision. This is called collision. K2 and K5 both are trying to take us same place, which is practically not possible. Fine. So this statement is discussing about this figure. I've already explained you. Now comes, if there is a collision, then what is the method to resolve collision? So let's see. There are two methods for resolving collision. One is collision resolution by open addressing, and one is collision resolution by separate chaining. So what is, we'll discuss first we will discuss open addressing. So collision resolution by open addressing means, in open addressing, if I say in open addressing, all elements are stored in hash table itself. So in open addressing we use a hash table and all the elements are stored in hash table, even though there is a collision. But what we'll try to find out a next free space. That is, each table entry consists of a component of dynamic set or nil. That is, we'll get to find something new for that element. When searching for an item, we consistently examine the table slot until either we find the desired object or we determine the element is not in the table. So in case we are searching, till when we search, we keep on searching until we get that element, or if the element is not present, we say element is not present. This is very important line, very important. The process of examining the location in hash table is called probing. That is, the process of examining the hash table is called probing. That is, we are examining the hash table. So open addressing technique are divided into three parts. We can do open addressing by linear probing, by quadratic probing, and by double hashing. And these three methods are, again I am saying, collision resolution technique, which comes under open addressing, Fine. So open addressing has three techniques, that is linear probing, quadratic probing, and double hashing. But in this video we'll discuss only linear probing. So let's start with linear probing. So what is linear probing? I'm giving you an example. I'll not read all those stuff. So I'm giving you a very good example. Suppose I'm giving you example. As we have already discussed, 0, 1, 2, 3, 4, 5, 6. Suppose this place is already occupied by 77, and on applying suppose on applying mod 11, no, to this 44, we get again what, 0. So again this 44 will try to come this place, but this is already occupied. So this is what collision. Now what I'll do in linear probing, I'll search for next space, that is 0. If 0 is filled, then I'll check second space. If second space is free, so I'll put 44 over here. Now suppose if this first place is also full, suppose there is 87, then I'll check next free space and I'll put 44 here. And suppose this 44, this second place is also filled with some other value, say 96, then I'll check other space and I'll put 44 here. So what actually I am doing? I'm doing a linear probing. That is, I'm doing a linear search. And the moment I get a free space, I put the value over here. But there is a problem. So it has a disadvantage. Linear probing is simple to implement. The advantage is that it is very simple to implement, but it suffers from a issue known as primary clustering. Why? Because there will be a cluster. No, you can see there is a cluster, because one thing very well is that the complexity of hashing is order of 1. But suppose now you have to search 44. What you will do, you will divide 44 with 11, because as we use 11 for storing the element, so you get 0. Came here and you found that 44 is not here. So what you will do, you will add 1 and you will get to the second position. You will find, oh, second position is also not having. You will add 1. You will again search the third position. Again you will see that in third position you are finding element. So what you are doing, the complexity is somewhat taking a place of order of 1. That is, it's creating a cluster. So linear probing can lead to greater complexity, but here we'll understand how linear probing is taking place. So this is all stuff. Now the formula which we'll use for linear probing is HKI. What is I? I'll keep from 0 to m minus 1. What is m minus 1? Number of no, size of hash table. What is m? Size of hash table. What is m? Size of hash table. Fine. Okay. Then h, the formula is h dash k. What is h dash k? Is k mod m, which we have already used, k mod m in division method. No, in this place what we'll put, k mod m, no, plus I, and after that we'll apply again mod m. So what is this I will start from 0. That is, if first place is full, then I'll put I value 1. If second place is full, I'll put I value 2. So I'll keep on doing same thing. So let's start with the question. Hope the question can make you understand this thing very clearly. So here you have a question on linear probing that consider inserting a key. You have to insert these keys using a hash table having size 11. Using linear probing, you have to use linear probing. Consider the primary hash function is k mod n. Fine. Okay. Now this is the initial value of your hash table, that nothing is there in hash table. Now what you do, first of all you will try to put 24. What is the formula? HKI is what? H dash k plus I mod m. This is the formula. Now you take I value 0. So H24 0 is what? 24 mod 11, m is 11, plus I is 0 mod 11. So 2 plus 0 mod 11 is 2 mod 11. Finally you get 2. So is 2 space free? Yes. Since T2 is free, we'll insert 24. So you can see that at second place we have filled 24. Now you have a 36. So 36 0, because I, first of all you start from ith value 0. So I is 36 0. So 36 mod m plus I is 0 mod 11, then 3 plus 0 mod 11, then it's equal to 3. So at third place you will insert 36. So is third place free? Yes, third place is still free. You will put 36 over here. Fine. Okay. Now you have to insert 58. You will do 58 comma 0, because currently you will use I value as 0. So 58 mod 11 plus 0, again with mod 11, then 3 plus 0 mod 11 will give you what? 3. You have to put 58 at third position. Is third position free? No, third position is already occupied. Since T3 is not free, so next sequence is you will put in place of 0 1. So 58 mod 11 plus 1 mod 11, 3 plus 1 mod 11, which is equal to 4 mod 11, and you finally get 4. And you will check, is T4 free? Yes, now T4 is free, so you put 58 over here. So finally when you get a collision, so 58 is giving you a collision. So what you are doing, you are incrementing value of I. You will keep on incrementing value of I unless and until you get a free space. And similarly you will insert 65, similarly you will insert 62, and similarly you will insert 86.